So today we're going to look at lesson 3-5, which is solving radicals or solving equations that have radicals. So any equation that has a variable in the radicand, which means under the radical, or has a variable with a rational exponent, meaning a fractional exponent, is called a radical equation. So an example might look like this. The square root of x cubed plus 1 equals 65. Then the next one, a radical equation in which the radical has an index of 2 is known as a square root equation. So an example of that would be the square root of x is equal to 9. So then we've got some procedures that you should always look to follow when solving a radical equation. So the first one is you want to make sure that you isolate the radical on one side of the equation. Just like you would isolate a variable on one side, you want to get rid of everything that's being added or subtracted to that radical, or anything that's being multiplied or divided to it. Once you have the radical on one side by itself, then you're going to raise each side of the equation to the power of the index. So if the index is 2, you're going to square both sides. If the index is 3, you're going to cube both sides, and so forth. Then once you do that, you should get rid of the radical, and then you can just solve for the variable. Now, there is another little issue right here. If you have the equation that has not a radical, but a fractional exponent, then you need to raise each side of the equation to n over m. So notice that this one's m over n, and you're going to raise it to n over m. These are reciprocals of each other. So, and you can see that here, so that if you had x to the 3/4, that's a 4, is equal to 10. I mean, I don't know. You would want to raise this side here to the reciprocal of 3/4, which would be 4/3, and you would want to raise this to the 4/3. And then you would be able to get rid of this fractional exponent because the 3's and the 4's would cancel. 3/4 times 4/3 is 1. So bear in mind that note. If m or n is even, then the value of x is going to be positive, just to let you know. So bear that in mind. Okay, so let's look at a couple of examples. So I'm going to make this really big. And all I'm going to do is just follow those procedures that we just outlined. So first and foremost, what you do to one side, you must do to the other side. So I'm going to get this by itself first. So that means I need to get rid of a -5. So I am going to add 5 to both sides. That gives me the square root of 4x plus 1 is equal to 5. Because my index here is 2, that means that I am going to square both sides. So a radical times itself is going to give you what's under the radical. So when you square that left side, you're just going to get 4x plus 1. When you square the right side, you get 25. And then from here, it's just like solving a normal equation. Subtract 1, and you get 4x is equal to 26. Divide by 4, and you get x is equal to 6. Now, anytime that you raise both sides of an equation to a power, you have to check this answer here to see if it's what's called extraneous, meaning does it work? So we're going to take this 6 and plug it into the original equation. Do you have to plug it in the original equation? Yes. So we are going to check. So all I'm doing is getting ready to substitute in. So instead of x, I'm putting in that 6. So then I've got the square root of 24 plus 1 minus 5 equals 0. The square root of 25 minus 5 equals 0. Square root of 25 is 5 minus 5 equals 0. Finally, 0 equals 0. It checks. So that means this is a good solution. It works. Sometimes in the process of squaring both sides here, this equation does not understand that it came from a square root where your answer has to come out to be positive. So then let's move over here and look at example 2. So you go ahead and do this one on your own, pause the video, and then come back and look at the answer. Pause it. Okay, so you should have isolated this radical by subtracting 4. Because your index is 2, you're going to square this side and square this side. So that leaves you with 2x minus 5 on the left and 9 on the right. So then we're going to add 5. And you get 2x is equal to 14. When you divide by 2, x is equal to 7. So then you got to check it. In the original problem. I'm going to put the 7 in where the x goes. I get the square root of 14 minus 5 plus 4 equals 7. 14 minus 5 is 9, so square root of 9 plus 4 equals 7. Square root of 9 is 3 plus 4 equals 7. 7 equals 7 checks, so this is a good answer. All right, so example 3, we now have a fractional exponent. So instead, and we still have to isolate the parentheses that's being raised to that fractional exponent, so we're going to have to isolate this x plus 3 because it's raised to this. This means that it has a radical because we've got the cube root of x plus 3 squared. So we need to get rid of this 2. So to undo the 2, we're going to divide this side by 2 and divide this side by 2. So the 2's cancel, and we are left with x plus 3 raised to the 2/3 is equal to 4. So now remember that if you have a fractional exponent, to make this go away and become 1, we're going to multiply it or raise this to the 3/2. So remember, power to power means we multiply exponents. So I'm going to take this and raise it to the reciprocal of 2/3, which is 3/2. As a power to power, you're going to end up multiplying these exponents and they will become 1, and you'll just be left with one of these. So what we do to one side, we have to do to the other side. So then that means on the left, I've got x plus 3, and on the right, I prefer to take this 4 and put it into its power form. So remember that there are 2 2's and 4, so I'm going to replace that 4 with 2 squared, because that's the same thing as 4, and I'm still going to raise it to the 3/2. So if I take 2 and multiply it to 3/2, this is 2 over 1, so the 2's are going to cancel, and I'm going to be left with just this 3. So I still have an x plus 3 on the left, but because the 2's cancel, I get 2 raised to the 3rd power. So x plus 3 is equal to 8. Subtract 3 from both sides. You get x is equal to 5. Then we need to check. So I'm going to check in the original problem. I'm going to put 5 in for x. So I get 2 times 8 to the 2/3 is equal to 8. So here's a quick way to check it when you have a fractional exponent. So this means the root. So this is the cube root of 8. Well, the cube root of 8 is 2, and then 2 squared is 4, and then 4 times 2 is 8. So 8 equals 8. Check. So x equals 5 is a good solution. Then for part B, it's almost like part A, except we have this pesky minus 1 here. So you're going to have to add 1 to both sides, right? And then you're going to have to divide by 5 to both sides. And so pause the video and try that one on your own and then restart. Okay, so in order to isolate this, we're going to have to add 1. So I have 5 times x plus 1 raised to the 3/4 is equal to 40. Then we need to get rid of the 5 in front, so I'm going to divide by 5. And so now I have x plus 1 raised to the 3/4 is equal to 8. Then I'm going to multiply, or I'm going to raise this to the reciprocal of that fraction. So the reciprocal of 3/4 is 4/3. Because of power to power, those are going to multiply and become 1. So that means I have to raise this to 4/3. And so on the left, I get x plus 1. I don't know why I'm putting that in parentheses. I can drop those. Is equal to, and then I'm going to change the 8 into its power form. So 8 is 2 to the 3rd, and then all of that is raised to the 4/3. So the 3's are going to cancel, and I'm going to end up with 2 to the 4th, because those are going to cancel, power to power. So I have x plus 1 is equal to 2 to the 4th. 2 to the 4th is 16. And then I'm going to subtract 1 from both sides, and I get 15. So then I need to check. So 5 so we're putting 15 in here. So I get 5 times 16 to the 3/4 minus 1 equals 39. Then 5 times, and remember, this is asking for the 4th root of 16. So the 4th root of 16 is 2, and then 2 to the 3rd power is 8. 5 times 8 is 40. And 39 is equal to 39. So it checks. So 15 is a good solution. Okay, so then let's move on to a word problem. So let me make this smaller so we can see it. And then let me straighten it up, maybe. Okay. So let's go ahead and read the problem first. So as we read it, you're going to want to stop and highlight certain things. So the size of meteor crater in Arizona, my favorite state, can be modeled by the equation d equals 2 times the cube root of v over 3/10, where v is the volume in cubic meters. So that's kind of important, that v is the volume in cubic meters, and then d is the diameter of the rim in, and then you're missing that part, in cubic meters. Oh, I'm sorry, no, the diameter would be just meters. So then part A goes on to say that the crater has a diameter of 1.2 kilometers. Well, that's a problem because everything here is in meters. And they're giving us the diameter in kilometers. Well, this equation only works if you put meters into it. So we're going to have to convert 1.2 kilometers into meters. So they want to know what the volume is, but let's start with the diameter. So I have to take 1.2 and convert it. So if you recall, you used a mnemonic in science that was King Henry died over, which is your unit of measure, meters, liters, grams, drinking chocolate milk. So this represents kilo, hecto, deca, units, deci, centi, milli. Okay? So you're going to take your item that you're trying to convert, and in this case 1.2, and we're going to put it under K for kilometers. So if I want to move the 1.2 from here all the way over to its unit of measure, 1 meter, then I'm going to have to move this decimal point 1, 2, 3 places. So I have to take my decimal and move it 1, 2, 3 places. So that means I have to add on 2 zeros as a placeholder. So 1.2 kilometers is identical to 1,200 meters. There are 1,000 meters in every kilometer. So now that we have that, we can go ahead and plug into our formula. So I'm going to plug in the 1,200 in for D, and then equals 2 cube root of V over 0.3. So then we need to divide by 2. So we're going to divide this side by 2. That's going to get rid of that 2, and this side by 2. So if I do that, I end up with 600 equals the cube root of V over 0.3. Because my index is 3, we're going to need to cube both sides. I'm going to raise this side to the third power to break apart that radical, and I'm going to raise this side to the third power. So 6 to the third power is 216, and then 2 zeros raised to the third power is 6 zeros. So we get 216 million equals V over 0.3. So now to solve, we're just going to multiply this side by 0.3 and this side by 0.3, and that is going to give us an answer of V equaling 64,800,000. And then the units of measure is meters cubed. How do I know that? Because we put it into a formula that says volume is going to be cubic meters. All right, so that wasn't so bad. You just had to plug and chug and use your knowledge of solving equations with radicals. So then I want you to do part B. So you're going to have to convert 1 kilometer into meters. So pause the video. Okay, so if you were listening closely, you heard me say that there are 1,000 meters in every kilometer. And so if we moved from kilometers to meters and we moved the decimal 3 places, and your decimal point's right here, you're going to have to move it 1, 2, 3, which means you have to add 3 zeros. Then 1 kilometer is equal to 1,000 meters. So we are going to put 1,000 in for D. Let me see. Okay, so 1,000 is going to come in for D. Then equals 2 times the cube root of V over 0.3. Then to isolate the radical, we're going to have to divide this side by 2 and this side by 2. So we end up with 500 equals the cube root of V over 0.3. Because my index is 3, I'm going to cube this side, and then I'm going to cube this side. Well, 5 cubed is 125, and 2 zeros cubed is 6 zeros. So we get 125 million is equal to V over 0.3. And then we're going to multiply both sides by 0.3 to both sides. And we will end up with V equaling 37,500,000 meters cubed. Good job. All right, so let's move to some more difficult equations, shall we? Perfect. All right, so let me make this larger. A little bit larger. Okay, so this is going to require some room. Lesson in your head, mark on paper, kill a tree. That's going to be our motto for this. Just trust me, it'll make it all better. So we're just going to remember our procedure. So the first procedure is that we are going to isolate the radical. So you can notice that we do have a variable outside the radical and a variable under the radical. We're interested in getting this radical by itself. So what you do to one side, you do to the other. So I'm trying to get that by itself, so I'm going to subtract 3. Remember that the x and the minus 3 are not like terms. So you get the square root of 5x minus 1 is equal to x minus 3. So because my index is 2, I'm going to square this side and I'm going to square this side. Please, please, please remember that this squared is not x squared plus 9 or x squared minus 9. It has a middle term. So I'm going to do it out the long way. The left side squared is 5x minus 1. That's easy. But the right side, you have to write out x minus 3, x minus 3. So then I've got 5x minus 1, and then I'm going to FOIL this. So I'm going to multiply the x to both of those. So I get x squared and minus 3x. Then I'm going to multiply the negative 3 to both of those, and I end up with another negative 3x and a positive 9. So that gives me a 5x minus 1 on the left, and an x squared minus 6x, because two negative 3x's do not cancel each other out, plus 9. I hate to break the news to you, but you have an x squared, which means that you're going to need to factor. And in order to factor, I need to get everything over onto the side where the x squared is positive. So I'm going to have to move the 5x and the minus 1 over here algebraically and get one side set equal to 0. So we're going to move the 5x by subtracting it to its like term, and we're going to move the minus 1 by adding it to its like term. So I have a 0 on the left, x squared minus 11x plus 10. So then, this is the easy factoring because we don't have a coefficient in front of here. So you're going to read this backwards. What factors of 10 add, that's an addition sign, hard to tell but true. So what factors of 10 add to give you 11? So the x squared becomes x and x. And the factors of 10 that add to give you 11 would be 10 and 1. Because the middle term is negative, the bigger of the two, 10, carries the sign. And then you have to decide what the sign of the 1 is. Well, the 1 would have to be negative to combine with a negative 10 to make a negative 11. Then, remember, if this product is equal to 0, right, then either this has to be 0 or this has to be 0. So you are going to set x minus 10 equal to 0 and the x minus 1 equal to 0 to solve. And you get, that's an arrow, and you get x equaling positive 10 or x equaling positive 1 if you solve those algebraically for the variable. Now we have to check. Always are checking. So I'm going to move this over a little bit so I have more room to check. So for 10, I'm just going to plug it into the original problem. So we're going to plug 10 in here, and then there's also another x out here. So I get the square root of 50 minus 1 plus 3 equals 10. The square root of 49 plus 3 equals 10. Square root of 49 is 7 plus 3 equals 10. And 10 equals 10, that checks, so this is a good solution. Then let's check the second one, x equals 1. So here we go. I'm going to do the same thing. I'm going to plug in our 1 this time. So I get the square root of 5 minus 1 plus 3 equals 1. The square root of 4 plus 3 equals 1. Square root of 4 is 2 plus 3 equals 1. Uh-oh, 5 does not equal 1. So that means x equals 1 is an extraneous root. It will not work, so we throw it out. So we only have one solution. Then the question part B says, when should you check for extraneous solutions? So anytime that we raise both sides of an equation to a power, you check. Okay. So let's up the bar a little bit. This time I'm going to give you 2 radicals. So we only have 2 more problems to do. This one and one that's a little bit of a challenge. So when you have 2 radicals, you want to move it so you have 1 radical on one side of the equation and 1 radical on the other. When you raise both sides to the power that you need to, you're still not going to get rid of all the radicals, so you're going to have to do it again. So if I have 2 radicals, I'm going to have to raise both sides of the equations to something twice. So have patience. So here we go. So I want to always move a negative radical if I can. So I'm going to move the negative radical x by adding radical x to both sides. So that leaves me with the square root of 5x plus 4 is equal to the square root of x plus 4. Because my index is 2, I'm going to square this side and I'm going to square this side. The left is not so bad. You get 5x plus 4, but be careful on the right when you, that's a plus, plus, plus. When you square the right, less in your head, more on paper, kill a tree. So we're going to write this out so that you can see how I get what I'm going to get. So I am going to distribute this radical x to both items in the next parentheses. So radical x times radical x is just x. Radical x times 4 is a positive 4 radical x. Then 4 times radical x is another positive 4 radical x. I'm going to line it up with its like term. And then 4 times 4 is 16. So as you can see, squaring both sides did not get rid of both radicals. It got rid of 1, but we're still going to have a radical left over. Four radical x plus 4 radical x is 8 radical x's plus 16. Okay, so then now we need to isolate the next radical. So we're going to try to get this radical all by itself. So I'm going to start off with moving the x. So I'm going to subtract x, and then I'm going to move the 16 by subtracting 16 from both sides. So I end up with 5x minus x is 4x. 4 minus 16 is minus 12 equals 8 square root of x. Then, at this point, if you try to divide this by 8 and divide this by 8, 8 is not going to go in here evenly or in here evenly. But this, and this are all divisible by 4. So it would be to your benefit to divide this by 4, divide this by 4, and divide this by 4 to make your numbers smaller. So you're going to end up with x minus 3 is equal to 2 times the square root of x. So normally I would insist that you divide both sides by 2, but it's going to make it real ugly over here. So because there's no variable here, I don't have a problem with you leaving it there. And because the index here is 2, we are going to square both sides to get rid of that radical. So again, be careful on this side because you've got a squared binomial. So less in your head, more on paper, kill a tree. So we are going to write out that binomial and properly FOIL it. 2 squared is 4. Square root of x squared is x. So x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. I could line those up, but I'm running out of room, so I didn't. Negative 3 times negative 3 is positive 9. Why is that 3x in red? I don't know. I just forgot to change colors. Perhaps I should erase that and make it prettier. And then equals 4x. Now because I have an x squared and it's not going to go away, I need to move this 4x over here so I can set one side equal to 0, and then I'm going to have to factor this. Yay! So here we go. We're going to move this 4x by subtracting it from both sides. And we finally have x squared. A minus 3, a minus 3, and a minus 4 is a negative 10x plus 9 equals 0. So I'm going to move this over a smidge. We are going to need to factor this trinomial to solve for x. Okay, so I'm going to do my work up here. So you want to ask yourself, what factors of 9 add to give you 10? The factors of 9 that add to give you 10 are 1 and 9. So I'm going to move this over. So we have, so the x squared becomes x and x. And the factors of 9 that add to give you 10, I said, are 9 and 1. And because the middle term is negative 10x, the bigger of the two carries that sign. The 1 is also going to have to be negative to combine with that negative 9 to make a negative 10. So then set x minus 9 equal to 0, and set x minus 1 equal to 0 and solve. You would get x equals 9 and x equals 1. So we have to check for that extraneous solution. So we have to check both of them. Painful but true. So I'm going to plug the 9 into the original equation. So I have the square root of 5, instead of x, I'm going to put the 9 in there, plus 4, and then minus the square root of x, and then equals 4. So I'm going to put 9 in here and 9 in here. And so I get the square root of 5 times 9 is 45, plus 4 is 49, minus the square root of 9 is 3. Then the square root of 49 is 7, minus 3 is 4. 4 equals 4, check. So this is a good solution. So We're going to check it again. All right, so this time I have the square root of and this time I'm putting in a 1 here and here. So 5 times 1 is 5, plus 4 is 9, so square root of 9 minus the square root of 1 is 1 equals 4. Square root of 9 is 3, minus 1 equals 4. 3 minus 1 is 2, does not equal 4. So we are going to throw that out. That is extraneous. All right, so let's move on to the challenge problem. So this problem is a bit more challenging. Let me make it bigger. Oh, it's a little crooked. You are going to need some room. That's why it's on a full page by itself. Okay, so the problem lies, yes, we still have 2 of these radicals, but this one's a little bit more complicated. So I want you to pause the video and attempt this problem on your own. You're going to do the same thing we just did on the last problem. You're going to move the negative radical over here, and you're going to square both sides. Don't be afraid of squaring something that has this in there. Really think about it. Just FOIL, first, outer, inner, last. You got this. You got it. Pause it. Try it. Go ahead, do it. All right, so hopefully you actually paused the video. You probably didn't, but I still have high hopes for my wonderful students. All right, so here we go. So I'm going to isolate, well, I'm going to put 1 radical on one side and 1 radical on the other side. So I end up with a square root of 3x plus 1 equals square root of x plus 1 plus a 2. Because my index is 2, I'm going to square this side, and I'm going to square all of this. So I get 3x plus 1 equals, less in your head, more on paper, kill a tree. So we are going to write this out. Square root of x plus 1 plus 2, square root of x plus 1 plus 2, and then we're going to FOIL. First, radical x plus 1 times itself is going to give you just x plus 1. Then radical x plus 1 times 2 is going to give you plus 2 radical x plus 1s. Then 2 times radical x plus 1 is going to give you another 2 radical x plus 1. And finally, that one's easy. 2 times 2 is 4. And on the left, we have 3x plus 1. That hasn't changed. So we have 3x plus 1 equals x. And then I'm going to add the 1 with the 4, but I'm going to put it at the end. So I have 2 of these, and I'm going to add 2 more of these. So I have 4 of those altogether. So plus 4 square root of x plus 1. And then don't forget we have this 1 here plus the 4 is equal to a positive 5. So we still have a radical. So we need to get that radical by itself. So I'm going to subtract x from both sides and subtract 5 from both sides. So we end up with 2x minus 4 equals 4 times x plus 1. So we could divide everything by 2, just like we did in the last one, because 2, 4, and 4 are all divisible by 2. And normally I would divide this side by 4 and this side by 4, but you can't divide that by 4. It's going to give you a fraction, and who wants to deal with that? But I would prefer to deal with some smaller numbers. So I'm going to divide this by 2, this by 2, and this by 2. So I end up with x minus 2 is equal to, the 2 is going to divide into the 4 here, so I get 2 square root of x plus 1. Now my index is 2, so I am going to square this side, and I'm going to square this side. Less in your head, more on paper, kill a tree, so we are going to write this out and multiply it the long way. We'll do that in a minute. And then you have to square this 2, so 2 squared is 4. And I have to square this radical. So the radical times itself is x plus 1, but remember it's being multiplied to the 4, so I have to use parentheses, and I'm going to have to distribute into here. So let's FOIL on the left first. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is another negative 2x. And then negative 2 times negative 2 is a positive 4 equals 4 times x is 4x. And 4 times 1 is 4. Then let's collect like terms. And so I now have x squared minus 4x plus 4 equals 4x plus 4. Since we have a squared term, yes, we're going to have to factor again. So I'm going to move this up. So I'm going to move the 4x over here algebraically and the 4 over here algebraically. You'll be surprised because not everything cancels as you think it should. So I'm going to subtract a 4x, subtract a 4x. Those don't cancel because they're the same sign. Subtract a 4, subtract a 4. Those will cancel because they are opposite signs. These cancel, these cancel, these cancel, but these do not cancel. So be careful. So what we have is an x squared minus an 8x is equal to 0. Since we have a binomial, the only thing we can do is take out a greatest common factor. Since this has an x and this has an x in common, we are going to divide each of these by x and pull that x out in front of parentheses. So x squared divided by x is x, and then the x's here cancel, and so you're left with a minus 8. Oops, that's not at all what I wanted. Let's try that again. How about this? So since this product x times x minus 8 is equal to 0, either this is 0 or this is 0. So you're going to set the x equal to 0 and the x minus 8 equal to 0. That's this being equal to 0 and this being equal to 0. Now one of them is already solved, so one of our possible values is x equals 0. Solve this for x, you are going to get x is equal to 8. So of course we get to check it. So here we go. In the original problem, so hopefully you have the original problem handy because I clearly have run out of room. So I'm going to check both answers. So check. We are almost done. Okay, so my original problem was the square roots of 3 times x plus 1 minus the square root of x plus 1 equals 2. So wherever there was an x, I'm going to start off with putting a 0. So 3 times 0 is 0, plus 1 is the square root of 1, minus 0 plus 1 is the square root of 1 equals 2. Well, the square root of 1 is 1, minus the square root of 1 is 1 equals 2. You got 0 not equaling 2. So we're going to go over here and we are going to kick out our x equals 0. That one's extraneous. So then we're going to check x equals 8. So in the original problem, we've got so this time I'm going to put 8 in for x. So 3 times 8 is 24, plus 1 is 25. Minus 8 plus 1 is 9. So the square root of 25 is 5. The square root of 9 is 3, and equals 2. 5 minus 3 is 2, equals 2, and that checks. So we're going to go back over to our solutions, and x equals 8 is a good solution. Whew, you did it. All right, so if you have any questions on your homework, please feel free to let me know. Good luck.